Okay. All right, so today we're going to look at another method. It looks like I erased too much earlier. Another method for graphing quadratics, and today we're going to look at it using intercepts. Okay, and some textbooks may call this intercept form.
Miss Willoughby, do we need to give these back to you, or can we like hang on to them? Or?
I think you can hang on to them. Okay, so we know how to graph this. We know how to do negative b over 2a and find the vertex, don't we? But today we're going to look at a different method. And this is find an intercept form by factoring. And we'll talk about why this works. So we have this function f of x equals x squared minus 8x plus 12. Which factors nicely, doesn't it? What does this factor to? 6 and 2 were right. Good. It's going to be x minus 6 and x minus 2 because we're multiplying and getting a positive and adding it and getting a negative. Does that make sense? Okay. Now the reason we would call this intercept form is because what is the y value at every x-intercept? The y value is what? 0. What does f of x represent? The y value, or the value of the function. So here, if I plug in 0, doesn't that say my y value is 0? And we're solving to find our x value. Okay, do you see this as a product? I have two factors here that are being multiplied. And what's the only way that a product can equal 0? Is if one of the factors is 0. So what would x have to be right here to make this factor equal to 0? 6. What would x have to be here to make this factor equal 0? 2. So what are my x-intercepts? 6 and 2. So I can plot those on my graph. 6 and 2. No, that's not. These are notes. You can take them or you can watch and print them later. Either way, I'm not making you do either. Okay, well that's only part of my quadratic. It's just 2 points. It's nice to have the vertex. How will we know where the vertex is? That does give us, we know we could do negative b over 2a, but isn't a quadratic symmetric?
Yes, halfway in between.
It's halfway in between. The vertex always lies on that axis of symmetry. So it's going to be halfway in between these 2 points. It's going to lie on this axis of symmetry. So what is the x value at the vertex? 4. So we could just add these 2 up and divide by 2? Is that how we get halfway in between?
Yeah.
Yeah, add those 2 and divide by 2. So we know the x value at the vertex is 4. How can we find the y value? Plug 4 in. If we plug 4 in here, we get 4 squared minus 8 times 4 plus 12. So we get 16 minus 32 is negative 16 plus 12 is negative 4. So my vertex is 4, negative 4. Now, that's not the only way I could have done that. We learned how to graph these initially in vertex form by looking at moves. Do you see that both of these are 2 units away from the axis of symmetry? What is 2 squared? 4. And how do I know I go down 4 instead of up 4? Because it is positive. It has to open up. Yes, sir.
When you're plugging in the value for the axis of symmetry when it's factored out? Can you just do it when it's factored?
Sure, plug it in here. That's fine. Okay, you try.
It's gratitude.
Yes, please.
I'm so sorry.
It says it's muted.
Can I get that checked out?
Yeah, my phone does that incessantly when it's the grading period, and Infinite Campus is going nuts. Because Jake is in elementary school, so he gets like 42 grades per grading period. Because you get all the letter grades, and then you get all the S's and
What's the
satisfactory. Then you get the 1s, 2s, and 3s. Grade level, above grade level. Not above grade level. Somebody remind me at the end of class that I have to run to a parent conference.
What?
I have to go to my son's parent conference since I'm the parent. Does anybody need help?
Just put them in the middle and plug that number into the equation. It's way easier. Yeah.
Is it? It's going that way though. Oh no, it's minus 15.
Oh.
Oh, dang.
And just locked in.
Yeah, I did that. It's negative 16. Okay. Plus negative 2 is now 1. That's gone. That's 1 right there. That'd be negative 1. Minus 15. Wait.
Negative 1, negative 21. How did you get your
The axis of symmetry is 1.
Oh, negative 6. Oh, yeah. You're right. I see.
How'd you do?
No, it's definitely a negative 1. No, it's a negative 1 regardless.
Halfway in between negative 5 and positive 3 is negative 1. Or you can say if I add them and divide by 2.
Oh,
Average them.
Yeah, you did. Yeah, you did.
Yeah, the signs mixed up. Whatever. At least I didn't get 21.
Why?
Okay, any questions? How do we do? All right, so now we have lots of choices for graphing a quadratic, don't we? Vertex form, and then doing the negative b over 2a, or factoring. We have lots of choices. Okay, now this one, we're going to do it by factoring, but it might not be first choice. This one doesn't factor as nicely. It's not terrible. So if I put 0 right here, and then I wait for y'all to catch up with me, we'll talk about this one.
Football club.
All right, so this one, what do you think it'll factor to? We know it's negative and negative.
2x minus 1 and x minus 5.
2x minus 1 and x minus 5. Y'all are too good at this now. All right, so if you can't just look at this and tell what it is, we know that either this factor or this factor must equal 0 for this to be true. So if you can't just look at it and tell, you could just set it equal to 0 and solve.
Yes.
So we get 2x equals 1, so x is 1/2. You might just look at it. It ends up being negative b over a every time. You know, when you solve this, it ends up being negative b over a. So it ends up being the opposite of this divided by that every time. Just because that's the process of solving it, that's what happens. Okay, and this one we can just tell by looking at it. So we know we have an intercept. Oops, I'm going to move my line over. Make it a little nicer for me. There we go. So 1, 2, 3, 4, 5. I've got one at 5. And then I've got one at 1/2. Yeah.
Oh.
So where's the axis of symmetry?
2 and 1/4 to the right of that.
So we take 5.5
2 and 3/4.
and divide it by 2. So we get x equals
2 and 3.
2.75. 2 and 3/4 is correct. My vertex is a little uglier. 2.75, comma.
Where do you get 5.5?
We said it's halfway in between, but to find halfway, you can take your two intercepts and average them to find in between. Halfway in between, you average the two, and that gives us halfway in between. So that's how we got the 2.75. Okay, so now we have to put this in. You want to put it here or you want to put it up here? Doesn't really matter. Okay, if we're doing it up here, then you get your calculator out and you punch it in, because that makes life a lot easier. And we have them.
Yeah, we do.
Negative 70.15, no?
10.125, yes.
Alright.
So we'll call it down here somewhere. We'll call that 2.75, comma, negative 10.125. And I just did a sketch here instead of an actual graph. Woo!
Sketchy.
It is a little sketchy. Very good. All right, make sense?
Wow.
Okay. All right, this is the easiest kind, but I want you to try it, because y'all crack me up with your factoring sometimes.
Okay, well.
Find the zero.
Oh, we're not to number 5 yet. You don't know what that means just yet. Okay, did you get negative x times x minus 6? So what would make this factor 0?
0.
0. What would make this factor 0? 6. Okay, so if we factor out just the GCF here and we have an x in it, then it's going to cross the x-axis at 0. So we have one at 0 and one at 1, 2, 3, 4, 5, 6. we factored out the GCF,
Yeah.
which was x, and I actually factored out a negative x, because when the leading one's negative, we always factor out a negative.
So you just have to like solve for the x for like each separate term. Like, oh no.
Alright, so what is the x value for the axis of symmetry? X equals what? 3, halfway in between. So my vertex
3, 9.
is going to be 3, 9. Let's see if that makes sense. 3, 9 would be up here. Does it make sense that this one opens down? Yes, because the negative was there to start with. Okay, intercept form of graphing. Are we good?
Yes.
All right, so just another option. Okay, now, the next thing I'm going to talk about is not actually graphing it. It's when they ask us to find the zeros of a function. Well, when they ask us to find the zeros of a function, does it make sense that is where the function has a value of 0? Where the function has a value of 0. That's what a 0 is, where the function has a value of 0. So what would we plug in for the function part? 0. So if I took the same problem and I just asked you not to graph it, but asked you to give me the zeros of the function, whoops, forgot to erase them. The zeros of the function would just be after we hit this, the zeros of the function are 0 and 6. So you try this one. Find the zeros of this function. Did you get the zeros of the function? Are -1/2 and -7. Those are the zeros of that function. Those are the values for x that make that function have a value of 0. Okay, and the other way we can see it worded, do you see that this function, it's just an equation. And so we have an equation, and you might be asked to solve the equation, or you might be asked to find the roots. The roots are the solutions to this equation. So, all those others, what did we do first? We set them equal to what?
0.
Okay. So what would we do with this one?
Set it equal to
Set it equal to 0. And we're going to find these solutions by factoring. It's not the only way, but it is one way. Okay, is this a perfect square?
Yes.
Is this a perfect square?
Yes.
So how can I write it?
3x plus 2 squared.
3x plus 2 squared, double the product checks. Yep, I'm good. So this one actually only has one solution. What is it? -2/3. So if we set this equal to 0 and solve, or if we just did negative b over a, it's -2/3. Okay, what would it mean instead of if I did not give it to you in this form, if I gave it to you in this form? And you immediately factored it. This tells me, if I did it in this form, this tells me it has one x-intercept? What would it make that x-intercept if it only has one x? It is the vertex. So we could write it as a binomial squared. This is going to just hit the x-axis and bounce back. This is the vertex. And if I wrote it in vertex form, to write it in vertex form, I would have to factor this 3 out of here, and it would look like this. Do you see that the vertex is at the opposite of this, negative 2/3? 0. And this is a horizontal compression by a factor of 1/3. Okay, now this was bonus. This is what you need to know up here. All right? Okay, your homework is out of your book. We're doing geometry, workbook, starting on page 357. We're going to do 1 through 6. And then on page 359, we're going to do 3 through 10.